All right, tonight we're going to have our final Zoom session for Survey of Contemporary Mathematics. This week we're in Chapter 12 and we'll be taking a look at geometry. In our textbook, I'm going to be completing the review exercises off of page 581 and 582 if you'd like to participate by looking along at those problems. I just want to go over a few definitions before we start. Complementary angles are two angles that will add up to be 90 degrees, and supplementary angles are two angles that add up to be 180 degrees. You should also know that all three angles inside of a triangle will add up to be 180 degrees. All right, so we're going to get right into these examples. We've got lots of different geometric shapes to look at, area, perimeter, different things like that. So once again, we're on page 581, the Chapter 12 review exercises. So there's a lot of formulas in this chapter, so I'll just be presenting those to you as they relate to the problems that we look over, but you'll want to have that book handy as you work through the apply this week, just to have those formulas in front of you and as you prepare for this week. So number one says the diameter of a sphere is 1.5 meters. So find the radius of the sphere. Well, a sphere is a ball shape. So, like a basketball or a volleyball, baseball, those are spheres. Of course, they're round, but they are three-dimensional. So, it's not a very good picture, but anyway, the diameter of a circle is the distance across that circle. It's a chord whose endpoints are on the circle, but a diameter is special because it passes through the center of that circle. So if the diameter is 1.5 meters and we're looking for the radius is half of that. So we'll take 1.5 and divide that by 2, and then our answer would be 0.75 meters or 75 hundredths of a meter. Okay, so the diameter is twice the radius, or the radius is half the diameter. Number 2, it says find the circumference of a circle that has a radius of 5 centimeters and use 3.14 for pi. So the circumference of a circle is the distance around the circle, and that formula is pi times diameter. Okay, so if we know that the radius is 5 centimeters and the diameter is twice that, okay, so then this half is 5, so that makes the diameter 10, and we're going to use 3.14 in the place of pi. So that means we're going to multiply 3.14 times 10, and that will give us an answer of 31.4, and then our label is centimeters. Make sure that you label appropriately for each of the problems this week. All right, number 3 is asking us to find the perimeter of the rectangle. Perimeter is like circumference. It's the distance around that shape. So what we need to know about rectangles is that opposite sides are equal to each other. So I can just simply add up 8 plus 5, 8 plus 5, or I can double the length and double the width. So that would be 16 plus 10, or 26 feet. Perimeter, circumference, that label stays the same. So feet, and this one was centimeters. Okay, and number 4, I'm given that AB is 15, and the measure of CD is 6, and the measure of AD is 24. So I am asked to find this little section right here. What is BC? So I'm going to add up the parts that I know. 15 plus 6 is 24. Excuse me, 21. And then I'm going to subtract that from the total. So 24 minus 21 leaves a measure of 3. So we see that the measure of BC is 3 units long. So once again, 15 plus 3 plus 6 should add up to be 24. next problem. We've got a rectangular prism, and we're asked to find the volume of this rectangular solid. So the formula for finding the volume of a rectangular solid is length times width times height. So that's what we're given, is length, width, and height. So we're going to just take those numbers and we're going to multiply those together. Because multiplication is commutative, it really doesn't matter the order that you multiply those in. 5 times 10 is 50, times 4 would be 200. Now watch out on the label here, because I'm multiplying feet times feet times feet. So that gives me a cubic feet. So I'll write that as feet to the third power. So 200 cubic feet would be the appropriate label for this problem. All right, number 6 says to find the unknown side of the triangle in the figure below. We have a right triangle, and what we need to know about a right triangle is when I'm trying to find the missing side, I can use the Pythagorean theorem to do that, which says a squared plus b squared equals c squared. C is always the side opposite that 90-degree angle. It's the longest side. We call that the hypotenuse. A and B, doesn't really matter which one is A or which one is B, but those are the legs. Those are the sides that make up that right angle. So I'm going to have 10 squared plus 24 squared, and that equals c squared. So 10 squared plus 24 squared would be 676. And then to undo a square, we take the square root. That'll cancel. And we have to do that to both sides. So the square root of 676 is 26, and that label will be centimeters. The thing to know about the hypotenuse is it is the longest side, so make sure that that answer is longer than the 2 legs. So once again, that's a squared plus b squared equals c squared. I was missing the hypotenuse, so I'll square those numbers and add them together, but make sure you take the square root of that number to get actual C. Okay. All right, number 7, if we go back to the definition we talked about at the very beginning, supplementary angles add up to be 180 degrees. So if I'm asked to find the supplement of a 105-degree angle, I will subtract 105 degrees from 180 degrees, and that will give me a supplementary angle of 75 degrees. Once again, if you're just joining us now, we are looking at the end of the Chapter 12 review exercises on page 581 from your textbook. If you'd like to join along with us there, you might could see these shapes a little bit better in your book. Number 8 says find the square root of 15 and round that answer to the nearest thousandths place. So the square root of 15 is not a perfect square root. So we're just going to have to round this. It's an irrational number. So the square root of 15, okay, we see that decimal right there. Sorry, that light is shining pretty bad. So that is approximately 3.872983. Just keeps going. But we're asked to round to the nearest thousandths place. So we've got tenths, hundredths, thousandths. But I do have to look at the number right behind it and decide 5 or more, bump up the score. 4 or less, let it rest. So that's going to be 3.873 when I round that off to the nearest thousandths place. So pay attention to the directions and make sure you round to the appropriate decimal place. Okay, number 9, we have 2 triangles, ABC and DEF. It says that they are similar. So we're going to find the height of triangle DEF. One thing to note about similar triangles is that corresponding side lengths are proportional. So what I can do is set up a proportion. In my first triangle, I've got the height and one of its sides. That will be proportional to the height in that corresponding side in the second triangle. So corresponding side lengths are proportional. So I've got 8 over 12 equals h over 24. And we learned in a previous chapter that we can solve proportions by cross multiplying. 12 times h will equal 8 times 24, and that is 192. And then I'll divide both sides by 12. So 192 divided by 12 would give us a height of 16 centimeters. Okay, so corresponding side lengths are proportional in similar polygons. Number 10, we have another circle, and it asks us to find the area of this circle. We know that the diameter is 9 centimeters, and we're going to use 3.14 in the place of pi. So the area formula for a circle is pi r squared. So we take the radius, square it, and then we'll multiply that number times pi. Well, they've given me the diameter. I can't use the diameter in this formula. So we learned back at the beginning that the radius is half of the diameter. 9 divided by 2 is 4.5. So we're going to take the radius, 4.5, and square it. And then we'll take that answer and we'll multiply that times pi, or 3.14. All right, so make sure to follow the order of operations. You need to square the radius before you multiply times 3.14. And that gives me a number of 63.585. And because I'm squaring the radius, I'm actually multiplying 4.5 centimeters times 4.5 centimeters. And so with area, our label is always square units. So this is approximately 63 square centimeters. And we'll write that as centimeters to the second power. All right, in number 11, we've got two parallel lines, line 1, line 2, and they are cut by this transversal. So you can see it creates several different angles with those parallel lines. And we're asked to find angle B and angle A. All we know is that this angle is 45 degrees. Well, there's a couple of things that we need to know about two lines cut by a transversal. There's a lot of angle relationships here that we can talk about. But in this relationship here, all the acute angles will be the same measure, and all the obtuse angles will be the same measure. So remember, an acute angle are angles less than 90 degrees. Obtuse angles are larger than 90 degrees, but less than 180. Okay, so because I know these are what we call vertical angles, these are equal. These are both acute, so they're going to be the same. 45 degrees in this angle B right here, these are called corresponding angles, and they are the same. And then these are alternate interior angles, and they are the same. But once again, all of the acute angles will be the same. So for part A, it asked me to find the measure of angle B, and I did that. It is 45 degrees. So now to find the other missing angles, including angle A. Well, we know that these angles are side by side and they form a straight line, okay? So a couple of things, they are adjacent angles. And adjacent angles are supplementary, which means they add up to be 180 degrees. So if I take 180 degrees and subtract 45 degrees from that, that gives me 135 degrees. So angle A is 135 degrees, but so are all of the other obtuse angles in this shape. They're all 135 degrees. So the measure of angle A will be 135. So they'll give you one angle, all of the acute angles are the same, and then all of the obtuse angles will be the same. But whatever angle they give you, the adjacent angle to that, okay, the side next angle next to it, doesn't matter which angle which direction you're looking at, those are supplementary and they'll add up to be 180 degrees. All right, number 12 says find the area of the rectangle below. The area formula is length times width, or base times height. So we're simply going to multiply 11 meters times 5 meters, and that will be 55 square meters. So we got a lot of formulas that we're reviewing tonight, and you should just brush up on those within the chapter 12 practice problems. All right, example 13 here says to find the volume of the composite figure shown below. Well, there really isn't a formula for helping us find the volume of this composite figure, but if you look at it, it really is just two rectangular prisms put together. So I can divide this up. I can draw a line here, okay, and I can see two different rectangular prisms, or I could draw the line here and see two different rectangular solids. Doesn't really matter how you do that, but we're going to separate those so that we can find each solid individually, and then we'll be able to add those volumes together. So let's kind of fill in what we know, because the volume of a rectangular solid is length times width times height. So I've got length, width, and height here, 7 times 8 times 3. 7 times 8 times 3. That's going to be 168 cubic inches. Okay, that's this bottom one. Okay, so I know that this portion is 3. It says that the total height here is 6, and if this part is 3, then this part must also be 3. And because this is 8, then it would indicate that these are also 8. So once again, length times width times height, 3 times 3 times 8 gives me 72 cubic inches. So we've got 2 different measures for each of those rectangular solids. Now we need to add those together to get a total. So 72 plus 168 would be a total of 240 cubic inches. That's the volume of that entire composite figure. So divide it into shapes that you can find the volume for, and then add those together. All right, number 14 says find the area of the composite figure shown below. Use 3.14 in the place of pi. We don't have a formula for this shape right here, but if we look closely, we see that it is made up of a rectangle, and it is made up of half of a circle. We call that a semicircle. So it's really easy to find the area of a rectangle. Length times width, okay? 8 times 4 would be 32 square inches, okay? We know that in a rectangle, opposite sides are the same. So that tells me for the semicircle that the diameter is 8. Remember, the area of a circle is pi r squared, but we're not doing an entire circle. This is half of a circle. So I'm going to have to take that formula and divide it by 2. Also, there's nowhere for me to substitute d, the diameter, in this formula. So I'm going to take half of that diameter. 8 divided by 2 would be 4. So in that formula, I'm going to use 3.14 for pi. The radius is 4, and we square that. And remember, because it's not a complete circle, it's only half of a circle, I need to divide that by 2. So in our formula, we have to square the radius. 4 squared is 16, and then I'll multiply that times 3.14. That's something like 50.24. And then I'm going to have to divide that by 2 because it is a semicircle, giving me 25.12, and that is also square inches. So the semicircle, we found that area. The rectangle, we found that area. So once again, we've got to combine those areas together to get the composite figure. So 32 plus 25.12 gives me a total area of 57.12 square inches. And I'm certain you're going to see some type of picture on the Apply this week that's similar to that. So divide it up into shapes that you can find the area of, and then you can combine those together. Because it was a semicircle, we had to cut that area of a circle in half. All right, so we're going to move along. This is on page 582 out of your textbook if you'd like to look along with us. All right, so number 15 says to find the volume of a sphere with a diameter of 8 feet, and use 3.14 in the place of pi. Round your answer to the nearest tenth. So remember, a sphere is like a basketball, that round shape. The volume formula for a sphere is 4/3 times pi r cubed. So up here they gave us that the diameter was 8 feet. But in my formula, I need the radius. So the radius is half of the diameter. 8 divided by 2 would be 4. So I'm going to substitute 3.14 in the place of pi. The radius is 4. Now your calculator we can use to do the multiplication and division here, as well as exponents. But make sure that you do this in the right order. Order of operations says I would need to do the exponents before I multiply these together. So 4 cubed is 4 times 4 times 4 times 3.14 times 4 divided by 3. So overall, we get a volume of 267.946, and that 6 just keeps repeating. But it did ask me to round to the nearest tenths place. So that's this position, and if I look at the number right behind it, 4 or less, we're going to let it rest. So we're going to round to 267.9. Volume is always cubic, so that's feet to the third power. Make sure to label that appropriately on your assignment this week. Okay, number 16, we have triangles ABC and DEF. It says that they are similar, and to find the area of the triangle DEF. So this time I'm looking for the area, okay? The area formula for a triangle is 1/2 base times height. I do know the height of this triangle, but I don't know the base of this triangle. But because they told me that these two triangles are similar, corresponding side lengths are proportional. So I need to find the base before I can go find the area. I've got the height and the base of triangle ABC. It will be proportional to the height and base of triangle DEF. Corresponding side lengths are proportional. And we can solve this proportion by cross multiplying. 5 times b will equal 8 times 9. That is 72. And then I'll divide 72 by 5. And that gives me 14.4 as the base here. Okay. So that's not the answer to the question. I was just filling in the base so that I can now go find the area of this triangle. So the area is 1/2 the base times the height. So we've got 14.4 times 9, and then we'll divide that by 2. So 14.4 times 9 divided by 2 is 64.8. And area is square units. So that's meters squared, square units. 64.8 square meters. All right, and number 17, we have another composite figure. It's asking us to find the perimeter of this one and use 3.14 in the place of pi. So you can see here we've got this cone shape. It's a triangle, and we know 2 sides of that. Because I'm looking for the perimeter, I just need the distance around it. So I do not need to add this part of the triangle into my problem. I need to add this part of the semicircle, the distance around that. So what we're talking about here is the circumference of a circle, which is pi times diameter. But once again, it's not a complete circle. Because it's half of a circle, we're going to need to take that circumference and divide it by 2. So starting with the circumference, that portion of the semicircle, we've got pi, 3.14, times diameter, and then we're going to divide that by 2. So that's 3.14 times 10 divided by 2. And we get 15.7 from that formula. But then I need to add 16 and 16 to this number so that I can get the full distance around that perimeter. So 15.7 plus 16 gives me 47.7 inches altogether. So in that last composite figure, we had to find the area. This one is asking for the perimeter. Okay, so notice those formulas are different. Area is the space inside, but perimeter is the distance around a shape. Okay, in number 18, we've got 2 parallel lines, line 1 and line 2. They are cut by transversal T, and they create quite a few different angles. But like we mentioned before, all of the acute angles are the same measure, and all of the obtuse angles are the same measure. So 80 degrees is an acute angle. It is vertical to angle B. So we talked about how vertical angles are equal, but all of the acute angles in this shape are going to be 80 degrees as well. This is alternate interior here, that's the same, another vertical angle, so those are the same. So I just found that the measure of angle B is 80 degrees. One thing to watch out for here, don't let this trip you up, is problem A, part A, ask for the measure of angle B. Part B, ask for the measure of angle A. So please don't get those mixed up on your apply this week in case it does that same thing. Now we need to find the measure of angle A. All that's remaining are these obtuse angles, and they're all going to be the same. We talked about before how adjacent angles, these angles that are side by side, are supplementary. They add up to be 180 degrees. So if I take 180 degrees and subtract 80 degrees from that, that leaves 100 degrees remaining. So because these are next to, side by side, they're adjacent, that means angle A is 100 degrees, but so is this one. They're vertical, they're equal. This is 100 degrees, it's side by side here. This adds up to be 180. And this one also would be 100. So the measure of angle A is 100 degrees. So all the acute angles are the same. All the obtuse angles are the same. Whatever angle you're given, the angle adjacent to that or next to that will be supplementary. That means they will together add up to be 180 degrees. All right, so now we're going to finish up with several word problems tonight. Number 19, we've got some home maintenance. It says, how high on a building will a 17-foot ladder reach when the bottom of the ladder is 8 foot from the building? So we may need to kind of illustrate what's being shown here. We've got a building wall and a 17-foot ladder. It's propped up against that wall. It says the bottom of the ladder is 8 feet from the building. So how high up will that ladder reach? That's the part that I don't know. One thing that you'll notice is formed here is a triangle, and it is a right triangle because that wall and the ground, they make a 90-degree angle. So what I'm going to use again, we did this in a previous problem, is the Pythagorean theorem. Remember, we use the Pythagorean theorem when we're trying to find the missing side of a right triangle. So the legs don't matter. This could be A or B, but the sides that make up that right angle are your legs. The side opposite or diagonal from that 90-degree angle has to be C. That is always the longest side and what we call the hypotenuse. So we've got x squared plus 8 squared equals 17 squared. Unlike that last problem, we were missing C, so we squared our numbers and added them together and then took the square root. But because I'm missing one of the legs, I'm going to have to square my numbers. 17, that's 17 squared is 289. Then I have to subtract that from 289. I've got to subtract the leg that I know. So that gives me x squared equals 225. Now that is not the length of my missing side because that would be way longer than the hypotenuse. I don't want x squared, I just want to find x. So now we finish off by taking the square root of 225, and that gives me an answer of 15 feet. So that 17-foot ladder can reach 15 feet up the wall when its base is 8 foot away from the building. So once again, that's the Pythagorean theorem. This time we had to square our numbers and subtract them before we took the square root. Okay, and number 20. Try to refocus here. Number 20 says a right triangle has a 32-degree angle. Find the measures of the two other angles. Remember, triangles have 3 angles, and all 3 angles will add up to be 180 degrees. So you have to find the 2 missing angles. but they actually gave you a second angle. Now we know that one angle is 32, but because they told me it was a right triangle, they indicate that one of those angles is a 90-degree angle. So if I add 90 plus 32, I get 122 degrees. I can subtract that from 180 degrees and find my third angle that's missing. So the two angles that I had to find were 90 degrees and 58 degrees. So make sure you give two answers because it's asking for the other two angles. They're going to give you one, okay? Because it's a right triangle, we know that one of those angles is 90 degrees, so we can add those up. All three angles inside of a triangle add up to be 180 degrees, so I can subtract that from 180 to get my final angle. All right. Number 21 says, a bicycle tire has a diameter of 28 inches. Okay, so here's a picture here. So the diameter of that tire is 28 inches. How many feet does the bicycle travel when the wheel makes 10 revolutions, 10 full turns, 10 circles? Use 3.14 for pi and round to the nearest tenth of a foot. Okay, so remember, as that tire is going around, we're actually finding the circumference of that tire. Circumference is pi times diameter. Okay, so we know that the diameter of that is 28 inches. One thing to notice here is that my information is given in inches, but it wants an answer in foot. So I'm also going to have to do some conversion here in just a second. So let's start with what we know. Pi is 3.14. I'm going to multiply that times my diameter, 28 inches, and that gives me 87.92 inches, okay? 87.92 inches, 3.14 times 28. Now that's just one turn of that wheel. We're making 10 revolutions, so I'm going to now multiply that times 10, and that will give me 879.2 inches. That's what 10 turns of that bicycle tire would be. That's how much ground it would cover. So now I'm going to take that information and I'm going to convert that into feet. We know that there are 12 inches in 1 foot. So if I were to divide by 12, then that will convert me over to 73.3 feet. Okay, so it's a multi-step problem. So I had to know that I was looking for the circumference. Circumference is pi times diameter, 3.14 times 28. Okay, and then I want 10 turns of that wheel to see how many feet that bicycle will travel. So that gave me 879.2 inches. And then lastly, I divided by 12 to convert inches into feet. So make sure to give your answer in the measurement that's asked of you on the problem. Okay, let me just jump down and do a couple more before our time is up here. Number 23 says a silo is in the shape of a cylinder. Okay, so think of a can. Is 9 feet in diameter. Okay, so the distance across that circle is the diameter, so that's 9 feet. And it has a height of 18 feet. So find the volume of that silo and use 3.14 for pi. All right, so in this shape, okay, our formula for finding the volume of a cylinder is to calculate the area of the base and then multiply that times the height of that shape. Notice the base of the cylinder is a circle, and the area of a circle is pi r squared. So the diameter is 9, radius is half of that. So I've got pi, 3.14, times the radius squared. So I've got 4.5, it's the radius, half of 9, 4.5 squared times 3.14. All right, let me calculate that. 3.14 times 4.5 squared gives me 63.585. Okay, so that is the area of the base. and we're going to multiply that times the height of the cylinder. So now I'm going to multiply times 18. It didn't tell me how to round, so I'll give my full answer. So that's 1,144.53, and volume is cubic feet. So don't forget to label that feet to the third power. All right, and just a couple more. Find the area of a right triangle that has a base of 8 meters and a height of 2.75 meters. It's a right triangle. You can draw it out if you want to, but the base is 8, the height is 2.75. But anyway, the formula is base times height divided by 2, or 1/2 base times height. So you're just going to take your base, multiply it times the height, and divide it by 2. So 8 times 2.75 is 22. Divided by 2 gives me 11. And area is always square units, so that's going to be square meters. And then one final problem here. If you travel 20 miles west, okay, so if we're going west 20 miles, and then 21 miles south, how far are you back to your starting point? Well, what you've just created is a right triangle, and that distance back to my starting point is my hypotenuse. Okay, it's that side opposite that 90-degree angle. And so when we are looking for a missing side of a right triangle, we can use the Pythagorean theorem: a squared plus b squared equals c squared. So once again, I've got 20 squared plus 21 squared equals c squared. Your legs, it doesn't matter which one is a or b, but the hypotenuse has to be c. So because I'm looking for the hypotenuse, I'll just be able to square these numbers and add them together. 20 squared plus 21 squared is 841. And my last step then will be to take the square root of both sides. So see, that hypotenuse would be 29 miles back to that starting point then. Okay, so once again this week, make sure to review the formulas for these shapes that we've talked about tonight. Be sure to label your answer properly, whether it's feet, square feet, or cubic feet, depending on what you're looking for. Our code word tonight is geometry. I've enjoyed working with everyone this past 6 weeks, and I hope our videos have been helpful to you. But don't hesitate to reach out if you've got extra questions this week as you prepare for our final week of class and as well the final exam.